Hi everyone, myself Dr. D. Swarnakar, Assistant Professor, Department of Mathematics, VNR VJIT. So in this lecture, I am going to explain how to find maxima and minima of function of single variable. So you take the heading as maxima and minima of function of single variable. Single variable. So this is the topic that I am going to explain. Let y is equal to f of x is a real valued function. Is a real valued function. So here I am taking y is equal to f of x is a real valued function. To find its extreme value means maxima or minima. Follow the steps. Step 1. Differentiate y is equal to f of x on both sides with respect to x. So according to step 1, differentiate the given function y is equal to f of x on both sides with respect to x. That is dy by dx is equal to d by dx of f of x. So that implies dy by dx is equal to f dash of x. So this is the step 1. Now coming to step 2, equate dy by dx to 0 to obtain stationary points of f. That is, equate dy by dx to 0 to obtain the stationary points of f of x. So here for finding the stationary points for f of x, we need to equate dy by dx to 0 according to step 2. Therefore, dy by dx equal to 0, that implies f dash of x equal to 0. So here f dash of x equal to 0 means it is an equation in one variable. So if you solve this equation, we will get some values for x. So that implies x equal to x1, x2, and so on, xn are the solutions of f of x equal to 0, which are known as stationary points of f of x. Okay. So according to step 2, after finding dy by dx, we have to equate the term to 0. Then you will get an equation. And if you solve that equation, you will get some values for x, and which are known as clearly stationary points of x. Now coming to step 3, find d square y by dx square by doing one more derivative of dy by dx on both sides. Therefore, d square y by dx square equal to f double dash of x. So according to step 3, we will have to differentiate again the term dy by dx on both sides with respect to x. So then it becomes d square y by dx square equal to f double dash of x. Then there exist the following three cases. Case A. If d square y by dx square greater than 0 at x equal to x1, which is the first stationary point of f of x, then f of x contains minimum value. Then f of x contains minimum value, and the minimum of f of x is f of x1. In step 2, we had some stationary points. They are x1, x2 and so on xn. In step 3, what I have done, I have find d square y by dx square. So in the d square y by dx square term, I am replacing the first stationary point x equal to x1. If d square y by dx square is greater than 0 at x equal to x1, then we can conclude the function f of x contains minimum value, that is f of x1. Next, case B. If d square y by dx square is less than 0 at the same stationary point x equal to x1, then f of x contains maximum value, and that is f of x1. So according to case B, if d square y by dx square is less than 0 at the same stationary point x equal to x1, then we can conclude f of x contains maximum value, that is f of x1. Next to case C. If d square y by dx square equal to 0 at the point x equal to x1, then f of x contains neither maximum nor minimum value. So according to case C, if d square y by dx square equal to 0 at the same stationary point x equal to x1, then we can conclude f of x contains neither maximum nor minimum value. then x equal to x1 is called saddle point in this case. So at a particular stationary point, if d square y by dx square equal to 0, then we can conclude f of x contains neither maximum nor minimum value. So at that time, we used to call the point x equal to x1 is called stationary point. Similarly, proceed the above three cases. For the remaining stationary points. That is x2, x3, and so on, xn. So here I tested the first three cases only for the first stationary point x equal to x1 to conclude whether f of x contains maximum value or minimum value or contains neither maximum nor minimum. So all these cases will also be proceeded for the remaining stationary points x2, x3 and so on xn. Okay. So finally, the maximum among all maximum values of f of x. Finally, the maximum among all maximum value of f of x, then that f of x is the maximum value and minimum among all minimum values of f of x, then that f of x is the minimum value. Okay. So that means after testing all these three cases for the remaining stationary points x2, x3 and so on xn, at some stationary points f of x contains maximum values and at some stationary points f of x contains minimum value. To conclude finally which is the maximum value of f of x and which is the minimum value of x, we have to identify the maximum among all maximum value of f of x and the minimum among all minimum value of f of x. Then the particular values are known as the minimum and maximum values of the given function y equal to f of x respectively. So this is the procedure to calculate minimum and maximum value of a single variable function. Example. So I am going to apply this procedure by solving an example. Example 1. Let y is equal to x square minus 3x plus 2. So here I am taking a function y is equal to x square minus 3x plus 2. According to the procedure, let dy by dx equal to d by dx of x square minus 3x plus 2. So that equal to d by dx of x square is 2x and d by dx of minus 3x is minus 3 into 1 and d by dx of constant is 0. 2x plus 2x minus 3 plus 0. So therefore dy by dx equal to 2x minus 3. Okay. So according to step 1, we did differentiation of y is equal to x square minus 3x plus 2 on both sides with respect to x. Then finally we will get dy by dx equal to x minus 3. According to step 2, let dy by dx equal to 0. That implies 2x minus 3 equal to 0. So that implies x equal to 3 by 2. So after equating dy by dx to 0, that means 2x minus 3 equal to 0, then we will get x equal to 3 by 2 is the stationary point of f of x. Is the stationary point of f of x. Okay. Next, according to step 3, we will have to find d square y by dx square for the given function y equal to x square minus 3x plus 2. So let d square y by dx square equal to d by dx of dy by dx. That implies d by dx of 3x minus 2. So we will get 3 minus 0. So therefore d square y by dx square is equal to 3. So the double derivative of the given function is d square y by dx square, that equal to 3. After getting double derivative of y is equal to f of x, we will have to follow the 3 cases of step 3 by substituting the given stationary points in d square y by dx square. Since d square y by dx square equal to 3 is greater than 0, at x equal to 3 by 2. Why? Because d square y by dx square is by default a positive constant. Even if you substitute the stationary point x equal to 3 by 2 in d square y by dx square, we will get that is positive. So d square y by dx square is greater than 0 at x equal to 3 by 2. Therefore, y is equal to f of x contains minimum value and the minimum value is the minimum value of f of x is f of 3 by 2. F of 3 by 2. That equal to 3 by 2 whole square, because we have f of x equal to x square minus 3x plus 2 minus 3 into 3 by 2 plus 2. If you simplify this, you will get 9 by 4 minus 9 by 2 plus 2. So if you simplify this by taking the LCM, 4, 9 minus 18 plus 4. So minus 9 plus 4 by 4. So 9 minus 18 is minus 9 plus 4. So that equal to minus 5 by 4. Therefore, the only minimum value of y is equal to f of x is minus 5 by 4 at x equal to 3 by 2. At x equal to 3 by 2. So this is an example problem which we have found the minimum value of f of x according to the procedure. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.